Thank you. Can you hear me? Yeah. So welcome to my talk, now just shortly after the lunch break. Thanks for having me here on the stage, by the way. And it's a real pleasure to be at the WeAreDevelopers Conference. Some really great people here. So what am I going to talk about today? I'm going to present Ohlala, but because it's my company, I'm the co-founder and CTO. But the actual topic of my talk is to build scalable web apps with React and Redux. I will just shallowly give an introduction to these topics because of time constraints, but I hope that you will learn something, even if you're familiar with these tools. So just a brief introduction about me. I used to be a researcher for 7 years at the Technical University of Dresden. I did research in theoretical computer science, tree automata, and also research and lectures in machine learning and natural language processing, particularly the translation of languages like English to French. Then after 7 years, I decided that I want to leave academia and want to do something that's more practical. It was always my dream to found and to see how it is to found a company. And then I met three other founders who were business people. That's what I wanted to look for because I did not have any business background. And then we decided to co-found Zoom, which was a company that made recommendation engines for the publishing media. For example, for making better advertisement, to have better matching between advertisement and readers. But then after 2 years, we realized that it's just too hard to compete against the great players like Google and Amazon. So if you want to build a technology, then you should not found a startup. You should have a large company and have a side team that can build that technology. That was a great learning. So after 2 years, I met Pia Poppenreiter. She's from Austria. You might have heard about her. And she had another startup before that when I met her called Pepper. And Pepper was about booking prostitutes online. So I met her that very night, and I talked about my startup, that it's a failure. She talked about her startup and said that she actually wants to do something new, maybe in a similar topic, but much softer. And she said that we might be a great team of founders. And I said, yeah, it's a great idea, but I'm not going to do that. But then I thought for 3 months about that, and I saw that it's extremely interesting and very challenging, so I decided to co-found with her Ohlala, the app for paid dates. So here's a picture of some people of our team. We are more, but this is not that recent. And we are a great team sitting in Berlin and have a lot of fun building this product. So now let me talk about JavaScript. I'm actually extremely impressed by the JavaScript community and by the progress and work that's done in this community. There's so much happening, and just half a year later, there is a bunch of new toolkits, libraries, and you need to learn over and over again. That's hard, but it's also very fun, and it's cool what's happening out there. I just want to give a brief sketch of how JavaScript programming used to be a couple of years ago. So you might remember jQuery. It's still important, but there are other things now. So jQuery, if you're not that familiar with it, it's more like you just build reaction handlers. Action handlers, for example, if you say that someone clicks on an element gadget, then you just want to, for example, say that in this case you want to show another element. So you click on a button and you want to show something else in the DOM. And that used to be jQuery. But if you want to have more involved web apps, like single web applications, then jQuery is just a hassle. And you're probably familiar with this kind of jQuery that's just complex and really messy. Now, when we built Ohlala, or when we started, we thought about what we should use. Shall we make a native app, or shall we make a web app? And we decided to go with the web app, just because there was it was not obvious whether we will be accepted for the App Store. So then we said, if we want to do a web app, then we need to look at all the tools that are out there. And there have been many libraries for single page applications, but there was a very new one, React. It's not that new anymore, but it's extremely interesting, and if you're not familiar with it, it's made by Facebook, and it's used on the Facebook webpage. And that's why we decided to go with React. So that you can better understand what I'm talking about, I just want to showcase briefly how Ohlala actually looks like. And in order to do that, I just need to leave the presentation quickly. So what you see here is Ohlala. These are two screens. These are two mobile devices next to each other because it's actually optimized for mobile devices. It behaves like it's a native app, but as I said, it's a web app. And here you see the male perspective, and on the other screen you see the female perspective. And what you want to do if you want to have a paid date is that the male first needs to make a request. So in order to request a date, he has to enter some details. When is the date going to start? How long should the date be? And how much he's willing to spend. That's just an indication because you're going to negotiate anyway later on. So now I send out this request. And just for the purpose of this demonstration, this there's only a 1 minute time frame. Usually it's in the live app, it's 21 minutes, so there's much more time. Now the woman has 1 minute in order to check whether might be interesting for her. And she will see a bunch of tiles on her screen. In this case, since this is just a staging app, it's only me in this situation. And now she can have a look at my profile and see whether this is interesting for her. If she says, yes, it is interesting for me, then she applies to him. Just need to make this a little bit smaller. And now he sees that there is one potential date. One woman said that she's actually interested in talking to this guy and getting to know him further. So let's wait for the remaining 5 seconds, because after this time is over, he's able to talk to or chat with all the women that expressed interest in him. So this is more like a carousel that he sees here, but since there was only one woman in our small staging environment, he can only see her. Now he can say that he wants to chat with her, then the chat opens and they can now just chat with each other like what you actually expect. And they can share images and they can agree on the date, negotiate the price, and after they chatted for a while, they can actually enter a price, and if everything is successful, then they can go on the date. So as you see, I know that there are some discussions here, but let's just focus on the app itself because it's a tech conference. So that's what I want to present. So you see that it behaves more like a native app. There are many screen transitions, highly dynamic. It's actually just a single web page all the time. It's the HTML element, the HTML document is basically empty, and everything is generated dynamically by using React. So let's go back to the app, and let me give, before I talk about React, let me also give a brief introduction about our stack, what we actually use. So on the front end, we use React, Redux, and TypeScript. And in the back end, we use Node.js, CouchDB, and Redis. But CouchDB and Redis is something, CouchDB is something that we are going to change because it's not that scalable. That's also learning. So I don't recommend CouchDB if you want to scale to a large cluster. So we will very likely switch over to either SQL or MongoDB in the next couple of weeks and months. So about React. As I said, who uses React in production? I just want to know. So it's not that many, okay. So it might be still interesting for many people here. React is done by Facebook. They use it on their web page. And React, as I said, is a framework for single web applications. But it's actually not as powerful as other frameworks, like, for example, Angular, because it's only responsible for the view. It's not responsible for the model or control or anything. It's only the view. So let me show how React works. In this simple example, you've seen this tile screen, and in React, you define components. So every single bit that's in the front end, every single widget and element is a component, and you define these components. And for example, in this example, on this screen, you see that I have these icon components up there that I can reuse. Then I have a component for this tile itself. So I can have many copies of these components. And there are other components like the user image, and you see there's the countdown element that counts down while you see this, and so on. And you basically define how these components behave and how they look like. And something that's also important is to know that these components can be hierarchical. So components can use other components inside themselves, as you saw before. And usually you have a lot of components. So we are in the hundreds, but on Facebook you actually have 2,000 components, which is incredible. I don't know where they are, but it's awesome, and it's a lot of work then. So let me show how React looks like if you look at code. This is a very simple component, a button component. And the simplest way to define a component is just to define a function that takes a couple of properties. It's an object having certain properties, and you return something that looks like HTML or XML, but it's actually JSX, JavaScript extended to look like XML. So I don't actually know what JSX means. It's an abbreviation, but I think there is no definition for what JSX is. JavaScript extended. And so here I just return a div, define the class name, it should look like a button, and the content of the div. Does it work? Yeah. The content of the div is just the label, just a string. And what else? I can define handlers. For example, a click handler, and I can define what happens if someone clicks on this element. And to show you how this looks like in a real environment, let's say I have a parent component that embeds this button. Then the parent component will define such a property element with, for example, the content OK. That means that that the button just has the caption OK. It will define a click handler that it gives to the button, and whenever someone clicks on the button, then React will take care that this click handler is called. So this is the basic information transport. Information is conveyed from the top of the DOM to the bottom elements, and you cannot reverse this information flow. The only way to do this is by calling click handlers or any event handlers that parent components give down to child components. Now let me talk about what's actually going on in the model. So as I said, React does not define what happens in the controller or in the model, just the view. So you have to come up with your own definition. And I think at the beginning, Facebook actually gave a recommendation of how to do that. And this recommendation is called Flux. It's rather a paradigm of how to transport information. And something that's special here is that it's a single, that information is only transported in one direction, never backwards. And or to tell you how this looks like is, if you go down to these views, so I already showed this view, this hierarchy of views. You have parent components, you have child components, and whenever an action happens in a child component, you usually call event handlers, and these event handlers then generate actions. Actions are just objects, and these actions are then dispatched to a dispatcher. Dispatcher is some very simple library or module that just conveys or takes the action and conveys it to a store. And the store is actually the model from the model view controller pattern. So the store is just a large object or a couple of large objects. In Flux, you usually can have multiple stores. And dispatcher just takes care to forward every action to every single store that wants to receive that action. So stores can say that they are interested in certain actions so that you can separate concerns. And the store at the end, when the store changes, whenever a store changes, it just tells the top element in the hierarchy to re-render itself. And this top element, when it re-renders itself, will also start to re-render bottom elements. Now, something that's still very important to know is how you deal with Ajax or asynchronous calls in Flux. And this can be quite messy, because Flux usually just defines how you have this information transport with the dispatcher, store, view, and action. And you can, if you want to define the information transport for Ajax calls, you can do very messy things. And that's actually what we did at the beginning, because it's just so much simpler. It's a lot of work to actually adhere to this rule just to have a single information flow. So because Flux is so simple and doesn't define clearly how to deal with Ajax calls and how to define stores, there have been a bunch of Flux implementations, libraries that tell you that give recommendations of how to actually implement Flux and that you can easily use. And there are a bunch of them. There are so many. I think I looked at on GitHub, there are around 50 or so Flux implementations. And it's actually a mess, and there is no standard yet. But there seems to be a new standard, and this is Redux. Redux is something very new. I think it has not been around a year ago. So at the last WeAreDevelopers Conference, I could probably not have talked about Redux because it's so new. But the Flux community or the Flux founders or the creators of Flux actually endorse Redux very much, and that's why I want to talk about Redux, and that's actually what we use by now. So Redux is based on three very simple principles. First is that there's only one single source of truth. That means that all the information is stored in one single object, the state. And another principle is that the state is read-only. That means you cannot change the state, you can only create a new state. And what you do, it's the third principle, is that you have reducers. These are functions that take a state and an action, take these two things, so the action just defines of how the state is supposed to be changed. And the reducer, this function, takes these two objects and creates a new object, a new state. And these three principles together have the effect that you can do very cleanly implement the information flow that's described by Flux. So since the time is already almost over, I would just skip this reducer example. We can talk about this later. I just want to say that you can structure the store, but there's still no time to actually talk about these details. I just wanted to show what we do. So we have a user store where we store information about the user, and we have stores where we store information about the other people that you are in contact with and about the chats. So I have to skip everything here. Unfortunately, just the last slide, just one single bit about the future of JavaScript. As I said, JavaScript is extremely interesting, but I think JavaScript will still be very important in the future. But regarding front-end programming, there's a new hero approaching. It's called WebAssembly. I don't know whether you heard about this. It's like an assembly language for front-end programming, and it's already around as a beta, as a prototype. But it will be very important in the future, and once this is around, front-end programming will be, there will be a revolution in front-end programming. So watch out for this, and thank you for the talk. Thank you for. Okay, so about the questions. I'm very happy about the first question, because this is actually a main concern. Push notifications, that's true. We cannot have any real push notifications. What we do instead is we send SMS. And you have to do this very intelligently, because you cannot send SMS as frequently as you do push notifications. So what we usually do is that when you're in a chat and there are incoming chat messages, that we collect these incoming chat messages, and after a couple of minutes, say 5 minutes, we send an SMS that contains that just says that there are new chat messages, and you should have a look at the app and see that there's new information for you. Next question, do you plan to switch to SQL database for higher scalability? If yes, which one? Yeah, I think the main benefit of having an SQL database is that you can create joins. This is usually a hassle in NoSQL databases. I know that in MongoDB there is a new thing that can simulate outer joins, left outer joins, as far as I know, but it's not the full power of SQL and of relational algebra. And we need to compute a lot of joins. Now we need to do everything in the Node.js app. This is actually not what you want to do. You want to compute these joins in the database and not in your app. So I think that's the main benefit of SQL for us, and that's why we consider to switch over to SQL. Is the content being indexed by Google? If yes, do you? No, everything in the app is not indexed by Google. The main purpose of our app is that, not the main purpose, but one of the ideas is that we want to protect user profiles. There's no user profiles are not public, and there's no way for any user who's registered on the app to browse other profiles just freely. That's not possible. So there's no catalog of profiles. Instead, you have to make a request, and when a woman applies to you, that's the only way that you can actually access her profile. And therefore, it doesn't make sense to index this by Google. Okay.
Thank you, Torsten, for the wonderful talk.